Hey guys, how you doing? It's Coach Scott with another edition of Purple Wave Chemistry. And this is just a review on types of reactions and balancing equations and just to get to the basics here, right? So let's talk first about balancing equations. Why are we trying to balance equations? We're trying to meet the law of conservation of mass, right? And so what we're trying to do is get the same number of atoms on the left hand side of the equation as the same number of atoms on the right hand side. That's really all we're doing. Of course, some things about equations, how we know what the left hand and right hand side is we have an arrow. And that arrow means yield or produces or whatever. So let's just do a simple one. Let's say we've got sodium and we're going to react that with I2 iodine. Of course, iodine is diatomic. It's always found in nature as that. And of course, the corresponding compound of that would be NaI. All right. So if you look right here, I've got one sodium on this side, on the left-hand side. I've got two sodiums on that side. All right. I've got two iodines on this side. I've got one on this side. I don't have the same number. So how would I fix it? I can only put a coefficient here, which means I'm doubling the number of moles. Okay. Or you could think about it on a molecular level as I'm adding another molecule. All right. So I'm going to put a 2 here. So that means I have 2 moles of NaI. All right. We know what a mole is. A mole is 6.02 times 10 to the 23rd number of particles. Or if we look at the nanoscale, that means I have 2 molecules or 2 formula units of NaI. So now I've got 2 I's, but it also means now I've got 2 NA's. I've got 1 Na on that side, so I'll put a 2 there, and now it's balanced. Another little hint, make sure you've got the lowest whole number ratio, and that is the lowest whole number ratio. So I have 2 NA's plus iodine plus or yields 2 formula units of sodium iodide. Okay, good to go there. Another part of these equations is we can say what state it is. So I know that sodium is a solid, it's a metal. So I'm going to put an S there. That S means it's a solid. Iodine is a gas. So I'm going to put a G there. And NaI, I think that is a solid. So we're going to put an S there. Okay. Another little L stands for liquid. Really, we're only going to use that with water for the most part. And then, of course, AQ, that's my AQ, means that it's aqueous. It's mixed in water. It's ionic. It's broken down into ions in water. Okay. So that's really the basics of balancing reactions, what you need to know, how to write the equations. Let's talk about types of reactions. So the first type we want to talk about is a synthesis or a combination. Either one would get you the point on a test. Synthesis or combination. That means what? You're combining or synthesizing 2 different atoms or reactants into one. So it's going to look, this is a synthesis or combination reaction. You had 2 elements, all right? They come together and form one. So that's got a form of A plus B is going to yield AB. AB being a combination of those 2 components. Now, when these occur, you're going to release energy. Release is energy. So when you have a combination, most of the time you're going to release energy. Things you need to know. All right. The second type of reaction, which you will see, is a decomposition reaction. Decomposition. Okay, so a decomposition is the opposite of a combination. You're decomposing something. you're breaking it apart. Let's use that one example here. So if I have 2 NaI over here, 2 NaI, 2 sodium iodides, and I'm going to decompose it through electrolysis, heat, something. All right, I'm going to have to add some energy into it. So that means I'm going to come up with 2 sodiums plus 1 iodine, like so. And I could put the states in there if I wanted to. But this absorbs energy. It needs energy, it requires energy. Either any of those would get you the points if you have such type of question. Okay, so this takes the form of what? The exact opposite. AB yields A plus B. Not hard. All right, the other type of reaction that we studied was what? Was a combustion. A combustion reaction. So a combustion reaction, for the most part, what we're worried about has a hydrocarbon. I'll pick one. Let's say you got C2H6. How do I know that's a hydrocarbon? Well, you got carbon and hydrogen. That's a hydrocarbon. All right. One of the reactants in any combustion reaction will always be oxygen. Oxygen gas, O2. Okay. Again, that's one of those diatomics. So it's going to yield 2 specific things. It's going to produce carbon dioxide and water vapor, H2O. That's what it's going to make. Now, to balance these, of course, it's combustion. You're lighting a fire. What's it going to do is going to release energy. That's pretty easy. So how would we balance it? Well, it's pretty simple. First of all, you're going to balance the carbons. I've got 2 carbons here. I got 1 carbon there. I'm going to put a 2 right there. Let's see if that'll do it for us. Then we got to do our hydrogens. So I've got 6 hydrogens there. I've got 2 hydrogens here. So I'm going to put a 3 there. Okay, so I got those 2 balanced. So let's see, I got 4. 2 times 2, that's 4, plus 3 oxygens. I got 7. That's an odd number. So I'm going to take that odd number, divide by 2. That gives me 3.5. So that means I got to put a 3.5 there. I can't have a 3.5, so I'm going to make that to a whole number by multiplying that by 2, giving me 7. That means I've got to multiply 1 by 2, which gives me 2. That's going to become a 4. And that's going to become a 6. So again, this is still, tell you what, let me erase that so that makes sense. And I just moved my screen around. That's not good. Okay, let me get my old thing here. And oh, I can fix that. Fix that. Fix that. Erase, well, come on, erase it. There we go. I'll fix that too. All right, so let's see. And I need to erase that so you can see what I write there. All right, that'll get it. So let's see, that was a C2. That was a plus right there. That was a CO2, and that's a plus. So that was a 1. That was a 3.5. That was a 2. And that was a 3. Ooh, that was a bad 3. 3. Move my hand around. 3. Okay, close enough. So I'm going to multiply this 3.5 times 2. Just erase that. Okay, and erase that 2. Erase that. Ooh, terrible 3. So that 3 times 2 becomes 6. That was a 2, so that's 4. That's now a 7. And now that was a 2 because it was a 1. So that gives me 4 carbons. Again, 4 carbons. That gives me 12 hydrogens, 12 hydrogens, and 8 plus 6 is 14. I've got 14 oxygens. The atoms are now balanced. That's what I want. Okay, so good. Let's look at our fourth type of reaction. And again, I am really giving you what you need to know. That is the single replacement. Single replacement. All right, this is going to look like this. You've got a metal or something, could be a halogen, and you're going to react it with a compound. We're going to call that BC, and it's going to yield the A is going to replace the B, so this B is going to be by itself, and it's going to have a new compound with the A replacing the B. Okay. Sometimes it releases, sometimes it requires energy. We're not worried about energy on this one, okay? Don't worry about it. So this will be something like this. Let's say we've got fluorine, and you're going to react that with sodium chloride, NaCl. So the fluorine will replace the chlorine. It's a halogen. So chlorine will be by itself, Cl2 plus sodium fluoride. Now that's not balanced, okay, but you've got A, you've got BC. Now, really, I guess you ought to call that C. Anyway, so C on this one is by itself, chlorine is by itself, and you've got a new compound. It's not balanced. Let's go ahead and balance it real quick. So I'm going to need a 2 there and a 2 there. Now it's balanced. So that is a single replacement where one thing replaces another one. Okay? Not hard to see. Definitely know what that looks like. The fifth type of reaction that we're going to worry about is a double replacement. Now this is going to be, take this form right here, AB plus CD, all right, and the A replaces the C, so it would be AD, and the C replaces the A, CB, okay, so let's see something. So anyway, what's cool about this is these are two clear liquids. Let me pause for a minute and I'll find one. Okay, I've got one. Okay, here's a good one. So I've got silver nitrate, AgNO3. All right, and these are precipitation reactions. So that's a aqueous. That means those are two ions in water. And I'm going to mix that with sodium chloride, salt water. Again, aqueous. It's in water. So it's going to yield silver chloride, AgCl, and that's a solid. It's going to precipitate out solution, and sodium nitrate, NaNO3, and it's going to be soluble because, again, it's following the SNAP rules. All right, sodium, nitrates, ammonium, or phosphates. So all that is potassium. All that is aqueous. It's soluble. All this is all soluble. All that's soluble. Silver chloride is not. It precipitates out of solution. Right. So these are no longer ions. Okay. There's your AB, CD, AD, CB. You had a double replacement. They replace each other. So, think about this. Some of these ions are just hanging out. They're called spectator ions. Now, what I do, okay, let me change color here. I find out what my my precipitate is, or what's my solid material. It's silver chloride. So that means this is doing something, that is doing something, but these guys are just hanging out. They're still ions. They're still out there in solution. So if I was looking for something that was spectating, not doing anything, it would be the sodium and the nitrate. All right. The silver and the chloride are doing something. All right. They're forming a new compound. The rest of them are still hanging out in the water. They're spectating. They're watching. They're not doing anything. So anyway, guys, you watch this and a couple of the videos on the BCA tables, which I put into this channel. I think you will do fine on our test tomorrow. Test coming up on Unit 9. Anyway, so this is Coach Scott saying Hullabaloo, connect, and have a great day. Bye.